All right, word problems. And this, for us this semester, this is the first long winded, tedious word problem we've got. So let's talk a little bit about solving word problems. First thing you need to do is understand that they're not stories. When you read a word problem, it's going to seem like far too much information. So read it a couple times and figure out what's going on. Okay? So after a decline between 1940 and 1980, okay, whatever, number of multi-generational American households. Okay, that's the first thing. That's what we're talking about is multi-generation American households. There's a function there I don't really care about the specifics at the moment, but it tells us it can be used to estimate the number of multi-generational households in the United States in millions. So what that means is if that function gives us a 5, that means there were 5 million multi-generational households. And I'm going to stop saying multi-generational. I'm just going to say households for sake of me not talking any more than I have to. X years after 1940, and then the source, I don't really care about that. So what we've got here is a function that, and the number that we put into the function, right, x, is how many years since 1940. So in 1950, we would put a 10 in for x because it's 10 years since 1940. For now, 2020, it would be what, 60 years from 1940 to 2000, then another 20, so it would be 80. We'd put 80 in for this year to find out how many households there are. Right? That's all there is to it. We have a function. We don't have to come up with it. It's given to us. And we know that x is a year, number of years since 1940, and the number that comes out of the function is going to be how many households there are. And we've got two problems down here. We want to know when there were 40 million households, so when that function reaches 40, and when that function reaches 55 for the second problem. So here's how we're going to do this. It's going to be entirely calculator based. Our first thing is, well, the first thing is turn the calculator on, of course, right? So go to your y equals screen and put in the function. I've already typed it in because there's no need to watch me do that. And then we're going to go to the graph screen. Whoops. I cheated. I did this once before. So we go to the graph screen, and if we're in our standard window, we don't see anything because our window is set up to go from negative 10 to positive 10 on the x-axis, and the same thing, negative 10 to positive 10 on the y-axis. And our numbers in this function aren't going to be between negative 10 and positive 10. So what we need to do is set up our window to show us the part of the graph that is actually relevant. Okay, so hit your window key. And we see here x min is negative 10, x max is positive 10. So that tells us that sideways, we're seeing along the x-axis from negative 10 over here to positive 10. And the same thing for y min and y max. Y min tells us how far down, y max tells us how far up. Let's go put x min at 0. And then we can arrow down. X max, I'm going to put at, what do we say, 80? Because it's been 80 years. So this will show us from 0, which would be 1940, to 80, which would be 2020. So it shows us everything from the start of this word problem to today. And then y min is always going to be 0. X min will always be 0. Y min will always be 0 for our word problems in this course. We need to figure out what to set x max at. And that is information that we can get in two places. One place is our table. If we go to second graph, that takes us to the table, and we can get an idea of what our y values are going to look like. Looks like they're in the 30s, but we also know they're going to rise. So I might set my y max at maybe 60 or something like that. Another place we can usually look is the questions we're being asked. It's asked when will it reach 40 and when will it reach 55, excuse me. So that tells me that I need to set my y max high enough that I can see 40 and 55. Okay, so let's go back to the graph. See, the graph goes down, comes back up, and I can use trace, as always, to find points on the graph. When x is 40, which is 40 years after 1940 or 1980, there were 31.6 million households. And I can continue to do that. And I could keep going over there to find when we get to 40, and it looks like it's somewhere between 54 and 55, so somewhere around 1995. But another way to go would be to do this, and I think this is easier. we've got our curve in Y1. In Y2, just put 40. And that will give us a nice horizontal line right at 40. And then we can do this. Second calc 5 for intersection. Enter, enter, enter. And we've done this before. So it's not new. Same keystrokes as before, and it tells us at 55 right there. So 55 plus 40 is 1995. There were 40 million households. For the second part, we're asked when it reaches 55, just move that horizontal line to 55. I don't know why it has to redraw the whole thing, but it does. There we go. Second calc 5, enter, enter, enter. And it will give us our intersection point here that says 71 years after 1940. So that's 2011. That's when we reach 55 million households. Okay, that's all there is to it. I'll do one or two more of these to give you a little bit of variety, but that's all the steps that I'm going to expect of you in the word problems here.